letting me or allowing me to be here. The title of this presentation is Infraestructures for Teaching, Learning, Laboratory Competences. And then I will go into details for application cases in electrical engineering. As most of the people here are from the education department, I will try to focus on the pedagogy side, okay? So that you may understand it, and feel free to interrupt me at any time. So if you have any questions, please just put your hand on the air and then I will stop. For addressing these three goals, I propose the following 5 sections. First of all, a bit of background, namely to introduce the problem and the solution. Then we'll go for a bit extended introduction, namely how to go from experimental competence to laboratory teaching. Then distinguish real laboratories, virtual laboratories, and remote laboratories. Then, what are the fundamentals, motivation, and characteristics of remote laboratories? And then, how you can use this type of laboratory environment in science and engineering courses. And this is for the introduction. Then we'll go into a bit of detail on the engineering side, namely to present some architectures of remote laboratories, requirements, examples, and a brief analysis and some conclusions. And then we go into the hands-on part, basic electrical and electronic circuits and some more complex circuits, and then we'll drive the conclusion and future direction. Okay, so 5 sections for the 3 goals. Engineering schools, they provide accreditation that someone is able to practice engineering. So when you go to an engineering school, at the end of that formation period, the school will tell to the society, this person is able to practice engineering. Okay? And for that, he needs to learn a lot of things and to practice engineering. So engineering is just not reading books. You have to demonstrate some real laboratory competencies. Now, there are 2 problems affecting this. One of the problems, and this is relevant in Portugal now, is that there are more and more students going into engineering schools. And the type of students that go into these engineering schools are more and more different. We have now people that are older than 23 years old, that the government allows these persons to try a second chance. So they apply for the university, namely at the Polytechnic level, and they can, if they have the grade for that, they can enroll in an engineering course. About 8 years ago, some people at the United States began to talk about what were the learning objectives of engineering education laboratories. So again, on this process, people started to talk about what are the learning objectives, the goals, right? This colloquy or summit was promoted by the Accreditation Board for Engineering Technology and the Sloan Foundation Society, that is a foundation for education at distance. So there was a large group of experts, about 50 experts gathered from all the United States. There was a first part of this summit where 3 experts talked about the problem of educational laboratories, what were the learning outcomes expected, what kind of educational technologies could you use for this, and then you divided these 50 people into different groups, and like in a workshop, you ask them to work about what are these learning goals, and then these people started to work, they gathered at the end, and they gathered a list of educational laboratories for educational laboratories. So one of the things is that we should, at this point, make a distinction between educational laboratories, laboratories for development, and laboratories for research. So they have different educational goals. Let's now go into the fundamentals of remote labs. So this part is now about the remote labs. There were 2 movements for achieving a remote lab. One on the technology side, and one at the educational side. At the technology side, first you had equipment controlled via electronic interface. So you can go back into 1954 and you find some instruments in nuclear plants that were controlled by an electronic device. Later on, with computers, you replace the electronic interface by just a computer program. Okay? Later on, because computers became networked, and we're talking here about 1980, 1990, with the advent of the Ethernet, the works developed at CERN. So you started to have all these computers connected. And with the web interface in 1993, with Tim Bickley, you end up with remote experiments. So this is a technology driving force. Some characteristics of the remote labs. This is a list of characteristics that we have recently published in a journal paper. This is more technical stuff, but I think some of you will understand this. The first of all is we would like to support all operating systems. Some people use Mac, some other people use Unix, some other people use Windows. One of the things is that you don't want your computer to not be included. You want everything to run from your computer. So from the other side, we have to accept all these kind of clients. The other thing, and this is a concern of the university, is security. You don't want to open ports because of virus, Trojans, all these problems that affect the networks of a university. So you just want everything to go through this port 80. The university will know this. The other thing is that you want to support all different types of web browsers. Some people like Safari, Mozilla, Internet Explorer, and you know from experience that when you are accessing some sites, they don't work the same with different web browsers. You don't want these applications to access your files. You want to interact both with equipment and other people. You don't have to install things. Many people don't like to go into a site and then pops up a window. You have to install this plugin. Click here, do you allow this? And many people, I don't want this. And they try to go for another solution. Nowadays, it's important to also include PDAs, smartphones, because many students are now using these kind of devices, iPhones, for instance. The other thing is bandwidth. This is not so much as of a concern now, but about 3-4 years ago, when we didn't have the large bandwidth, this used to be a problem. So, concluding remarks. The references are indicated alongside the presentation slides. The 3 goals for this presentation were: understand the problem and the proposed solution. So, each one of you has now to assess this at your own mind. So, did I understand the actual problem and the solution? Did I understand the fundamentals, the development process, some application cases and the future directions of remote laboratories? And finally, we were able to conduct a remote experiment. Thank you. Questions, please?